Welcome to this video tutorial where we want to show you how to process DJI Phantom 4 RTK data with Trimble Business Center 5.4 or higher. In this video we will show you how to import your DJI data and how to process it. There is also a tutorial available in Trimble Business Center. When you hit the F1 button and you type in the search DJI, then you should find then the import and process DJI aerial survey data entry. And here we can then see the steps that need to be done to process the data. To be able to run the baseline processing with the T02 file, there are some prerequisites needed. And typically when you fly a DJI mission and you run this in the professional pro mode, then you will contain the Rhinix OBS file and the according timestamp and event log file, and also the PPK raw bin data. This includes all necessary information that we need to run the baseline processing together with the T02 file, which will then also help us to run the whole process. In general, this video will follow these steps. So we will, in this case here, define a coordinate system. We will use the import function to get the DJI data in. We will double check if the antenna are correctly set for the DJI drone. Then we will import the T02 file, drag and drop it into the project, and therefore we can then run the baseline processing based on the T02 file. In this video we will not cover the second part, where you can also download from the internet your virtual reference station and run on this one also your baseline processing. After the baseline processing is done, we will take a look at the result, and then we will also start the relative adjustment and absolute adjustment, because then we can see also the settings that are automatically done in Trimble Business Center, because then our GNSS positions of our DJI drone imageries will be set to high precision, to 2 centimeters. And therefore we can then run the relative adjustment and absolute adjustment without measuring a single ground control point. Of course, we could also measure a ground control point or ground control points, and then this would then be also here in this tutorial mentioned, but we will stop here in this video with this part. So let's start. Let's take a short look at our data itself. And in this data itself, we see here that we have this Rhinix OBS file. We have, in this case, our event log file. We have the timestamp MRK file, and we have the ppk raw.bin file for this data. Important for us is that this data is in the same folder as our images. So the DJI folder with the images together with the metadatas for our Rhinix and timestamps. In this folder there's also the T02 file, but at the moment we need afterwards to manually drag and drop this into our project. So therefore you can have it also stored somewhere else. It does not need to be within this subfolder. I will just define for this project the coordinate system, and then when this is done we take a look at the next step. Depending if you are using a job file or some other files that define coordinate systems in TBC, you need to be aware that your GeoEat model quality is set to survey quality. This is important later on when we will do the baseline processing, and the GeoEat model quality does not is set to survey quality, but if it's set to unknown quality, then our high precision solution of our GNSS will not be taken into consideration later on in our relative and absolute adjustment, and then it will not start. So please just be sure that this is set to survey quality. Typically this is when you define a coordinate system, always in this mode, but just assure it. I will just save my project so then we can continue, and then all the data is set to my project folder. Okay, next step is importing our DJI data. You can either from the, if you hit F12, you can type in DJI and then you will see the import DJI command, or you go to the photogrammetry ribbon and here you find import DJI UAV data. So when you hit this part, then you will have here in the panel a file selection or folder selection button, and we will then select now our data. Please select the folder where your images and also your RINEX and timestamp files are located, and just hit OK and then hit the import button. TBC is now looking into our folder and is now importing the GNSS raw data, which is then the RINEX informations and the timestamps and event logs. And you don't need to change any settings. So in this case here, our RINEX data is already selected. Then in the antenna is already set. So in our TBC library of antennas, the Phantom 4 RTK antenna is already introduced and will be automatically assigned to your DJI data, which also includes the antenna offset. So the value here is set to 00, but internally we already are correctly correcting the antenna to the Phantom 4 RTK drone, and therefore this is already correctly assigned this correction. And finally, the receiver. This is why I talk about this video as a work in progress. This is now already a kinematic mode, correctly set. And then with the T02 file, that's what I assume, we will then get our receiver information additionally to our dataset, or we would then need the virtual reference station to be added in this part. Important for us is the start and end time. So we have here the time frame where the data is collected, and therefore we can then assign this correctly. Okay, so then we hit OK. And now additionally to our DJI images, we also import now the raw data of the GNSS data and also the timestamps and exposure positions, therefore from the timestamp, that help us now to determine afterwards in the baseline processing our positions. The import is finished. We see now here our footprints of the images. And when we take a look at the report, then we can see that additionally also we imported here our RINEX OBS file. And the report also gives us information about the DJI images itself, because in the DJI images we have EXIF information and also XMP tags that are set up from DJI itself. And one of the XMP metadata or tag is the RTK quality, which can be either 16 or 34 or 50, which means in typical unknown floating solution, or in this case a fixed solution. And 50 means there is already a fixed solution available for the DJI data. And DJI itself defines it here with the RTK standard deviation in 1 centimeter in position and 2 centimeter in height. But this will not be applied in our TBC project now. So this is the data how it comes. Yeah, so it can also be RTK 16 or 34 quality. But then when we have the Rhinex data and we have the timestamp files and also these PPK raw files, then we can process in TBC itself our baseline processing, and then we receive our quality. And then we also know based on what quality this is done. In the future, this would be definitely something interesting to discuss if we could already now go with this data into relative adjustment and absolute adjustment without measuring a single ground control point. But as we are not sure about the real quality of this and also no protocoling available, so we recommend to first run in TBC the baseline processing with the data. We have a protocol, we have exact accuracies, we have a very robust and good engine for this whole part. We get for each exposure information if it's a floating or fixed solution, and therefore we are currently in this case going this way, that we need to run in TBC the baseline processing itself. The report also mentions that there is a T0x file in the import directory existing, so we can import this file if we want, but we need to do this manually in this part. Further, the report is also mentioning what camera has been detected, and also if the camera includes already distortion corrections or not. So in our case, the camera distortions are switched off, so it's not undistorted. Internal model name of the DJI Phantom 4 RTK is FC6310R. So this is the internal naming model of the DJI drone. And then finally, we have our message that the coordinate system here is using the current project coordinate system, and the error, which is in TBC, I think the standard error is that we have unrecognized receiver with serial number unknown. And this will, as I assume, then be solved, because then our receiver will be the data in the T02 file, and then we can use this one for our current further processing. Okay, next step is then drag and drop our T02 file into the project. So we just take the file and move it into TBC, and then this data is then imported. And also here we don't need to do any changes, everything is set automatically correct, so we will not do here our changes. The reference station is in this case a static survey mode, which makes sense for me. I assume this is exactly what we need. So our reference is a static survey mode, our drone data is kinematic data coming with the GNSS data, and therefore we can then with this reference station and the GNSS data from the PPK from the DJI drone, we can then run our baseline processing and make our DJI positions accurate. Okay, so I say okay, and then we can see now here our reference station, the solo free base point, and this one has survey quality. Yeah? So this is important. Also, when we would not run the T02, if we would run with an internet download of a station, then we really need to be aware that this point here has survey quality, and this is defined here in these global coordinates. I think this icon. So if I'm not sure if I can here just click it here. Let me take a look here if I can get this done. Okay, so I have to go here to the points, and then here in the points select from this reference station this entry, and then we can here take a look. And I was mistaken, you need to have this as a control quality. Yeah, so our control point, in this case for the reference station, needs to have control quality to run, in this case, our baseline processing in the correct way. In case you want to have more information, there is also a tutorial understanding aerial photo station data, which was coming together in former days with the UX5 data and the Gatewing X100 data. And here it was also mentioned that you need to process the trajectory in the project. You must also import a raw data file containing the base station coordinate, and this must be control quality, and therefore in our case the same way. So also for us this point needs to be, in this case, in control quality. And that's it. This is all we need. We can now, with this information now, already see that the process baseline button is available. As any baseline processing, the distance of our reference station to our project itself is important. It should normally be within 20 to 50 kilometers. If it's up to 200 kilometers, then there are still decent solutions. Everything further away will, of course, reduce the quality itself. But I don't go into this, so we will now be able to run our baseline processing, and we can just hit the process button. It will automatically detect our data, our RINEX data, our, in this case, timestamps data, also our T02 file with the reference station. And then when the solution is done, we can here on the left side click this black arrow, and then the report button should be available. And then when we hit the report button, we can now see the solution that was calculated for our project. We can take a look to this session that we processed here on the left side, and then we can see here how many of our images have fixed solution, and in our case all of our DJI images have been available within 0 to 5 centimeter accuracy. As I understand from TBC, running with a T02 file, the baseline processing is automatically setting the correct interval. So in our case here, the processing interval was set to 1 second. If you do not run this with T02 files, but if you download from the internet your virtual reference station, then you need to be aware that you also download accordingly the data correctly with the correct interval. And then all the statistics here for this baseline processing are done here. We can see here our residuals and standard deviations shown here, and therefore we could of course also see if we have here extreme offshots or something that is completely missing in this part. But in general here, our quality here is always below 2 to 4 centimeters, and therefore our data here is well and fixed solution. We have a fixed solution for this part here. Okay, so therefore we can now continue with the next step, and this is the saving this solution. And now we can go directly into our relative and absolute adjustment. So we can here run the relative adjustment, the type point extraction between the photos. And as we already see here in the text, if the UAS data includes RTK vectors and a processed trajectory, and there are no round control points, then an absolute adjustment will be performed automatically after a successful relative adjustment. And this is exactly our case. Because our project, the GeoID model, is set to survey, we will automatically set for all our DJI drones the accuracy to 2 centimeters, and then we will then, after the type point extraction or this relative adjustment has been performed, directly start the absolute adjustment, and we will introduce our drones with 2 centimeter accuracy. So I will just run here this process and show you then afterwards the result, and I will just fast forward this part. Okay, the processing is done, and we can now apply the adjustment. And the adjustment applied in this case here also includes relative and absolute adjustment. We can take this and see this here. I will first here open the report file. I say yes, and in the report file we will see immediately. I will just show it before I go to the report file in TBC, so I will just minimize this one. I will come back immediately here. When we take here a look on the right side on this panel, we can see here in the status that the status is absolute adjustment applied, and therefore it was successful. There was the relative and absolute adjustment was successfully done, and therefore this is now correctly processed. Let's take a look at our report, and in the report I just want here shortly to show that our images, our DJI drone images, have been correctly set with a high accuracy, and you see this in the block adjustment settings. And here in the block adjustment settings, when we scroll to it here, then you can see here, I zoom a little bit in, that our GNSS standard deviations are set to 2 centimeters. And if this would not have been done correctly, then it would normally we set them with 10 meters, and then also the absolute adjustment would not have been done. Yeah, so you cannot start then when we don't have high accuracy positions for our images, and if we did not measure 5 ground control points. But in our case, no ground control point measured, and everything based on the high precision of our drone imagery. Okay, so far for this video. Going into this report file in detail will be a different video itself, but we would now be ready to continue our deliverables. So we could then go and into advanced UAS, go here and define our point cloud and our auto mosaic and generate this one based on the quality now of our adjustment here. Of course, including ground control points would help to make the accuracy more, better accuracy. We would have less noise in the point cloud on the ground because the camera calibration would be done in a better quality with a higher reliability. And also with the ground control points in general, we will then have also a better absolute positioning accuracy to reference data where we want to add the data to other projects. But for us, this is now our T02 processing with the DJI RTK Phantom 4 data. Thank you for watching this video, and I wish a nice day. Goodbye.